Hello Phoenix Space. It's my pleasure to be back here to answer some of your questions after my lecture on rocket science. There have been some absolutely amazing questions and a great deal of them, so I haven't been able to answer all of them, but I've picked out a few which hopefully I'll be able to answer in this video. Okay, so starting with this first question, it says, what is the furthest distance we ever sent a rocket? Now, this is quite a tricky and interesting question, so I'm going to change it slightly if you don't mind, because when it comes to rockets, actually, the furthest we really sent a rocket is just beyond the moon, really. Once a rocket runs out of fuel, it's not really a rocket anymore, it's just an empty tin can. And rockets are really only designed to get things off of the Earth's surface into space and give them a gentle push in the direction that we need to send the payload, the satellite or the people. So rockets haven't really travelled that far. However, satellites have. So I'm going to change this question slightly to, what is the furthest distance we've ever sent a rocket, a satellite? Now that's really interesting because we have actually sent satellites outside our solar system. Now the solar system is the Sun and all its planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune and Pluto, and the asteroids. But really, space scientists like myself, really think of the solar system as the Sun and what's contained within its magnetic field. So the Sun's got a magnetic field at the North and the South Pole, and it forms a big bubble around the Sun and all the planets. And we really consider that our solar system. Okay? And beyond that is what we call interstellar space. And this is the space between solar systems, other stars and their magnetic fields. And this is a really hot radioactive sea between, it's a kind of rough sea between the solar systems. We've actually sent 2 satellites out beyond our own solar system, Voyager 1 and 2. These were 2 satellites that were launched in the early 1970s to study the planets, take pictures of the planets in the solar system. And once they'd finished swooping around the different planets in our solar system, they were allowed to just fly off. And they were designed to do this because actually we didn't know where the edge of our solar system was. We didn't know where the Sun's magnetic field stopped. And so we launched these probes out, and it wasn't until 2012, I believe, that a satellite first started to get beyond the edge of our own solar system. Now, the distance between the Earth and the Sun is 1 astronomical unit, and that's about 150 million kilometers. Voyager 1, when it got to the edge of our solar system, was at over 120 astronomical units. That's 18 billion kilometers. Okay, so it's had to travel 18 billion kilometers, 120 times the distance from the Earth to the Sun, just to get to the edge of our solar system. And it'd be travelling for hundreds of years before it gets to the edge of another star's solar system. Okay, so the furthest we've sent a satellite is to the edge and beyond of our own solar system. Okay, here is another one. Is it possible to die in a rocket because of the amount of energy on the human's body? Well, when a rocket launches, the way I will interpret this is if the gravity, if the G-force at launch is so large, could it squash a human being? Probably not, no. Because at launch, a human being probably feels about 7 to 8 times heavier than normal. We call that G's in my talk, if you remember. I think Yuri Gagarin felt 9 G's, 9 times the pull of gravity, and he survived. The biggest G-force a human being has experienced and survived is about 50 G's. A doctor in America used to test himself using a rocket sled. I can't remember his name. But he used to strap himself into a rocket sled and fire himself down a train track on a rocket train, basically. And then rapidly speed up and rapidly slow down. And it's believed his body felt 50 times the pull of gravity. And he survived. So the body, he wasn't very well. And he had to go to hospital for a little bit of time. But he did survive it. So it is possible for the human body to survive the really extreme high gravitational forces on its body. Here's another question. Is it possible to have a nuclear powered rocket? Now, it isn't possible to have a nuclear powered rocket insofar as getting it off the Earth, having an explosion. People have thought about this, but it's really tricky because a nuclear explosion is very large and very quick. You could maybe put something on top of a nuclear explosion and hope that it would be blasted up into space, but nuclear explosions are so powerful and so unpredictable, it's really hard to think about that. However, people have thought about, and in fact satellites are nuclear powered, so sometimes if we're sending a satellite so far out into space that usually they use solar panels, but if they've gone really far out into space that the sun would be at such a great distance that we wouldn't be able to capture the sun's rays anymore, what we can do is put on board a miniature nuclear reactor, and the electricity generated by the satellite can be generated by nuclear power. Okay, so it is possible to use nuclear power. Some people have suggested in space, to get us up to the speed of light, to accelerate really super fast, we could drop nuclear bombs behind a spacecraft, ignite it, blow it up, and if the satellite's far enough away, it could ride along on that blast, and you keep dropping little nuclear bombs behind a spacecraft. They go off and you blast it a bit like a sail on the wind. You blow it and you'd have a big sail over your spacecraft, and the explosion would go and it would blow your craft and accelerate your craft. That has been put forward as an idea as well. Here's another question. When do you think we will go to Mars? Will we see humans on Mars in the next 20 or 30 years? Yes, I do think we will go to Mars, and I do think it will be in the next 20 or 30 years. NASA, the American Space Agency, the European Space Agency, the Russian Space Agency, Japanese Space Agency, Chinese Space Agency are all working together to actually make this happen. We're going to see, I suspect, astronauts back on the moon within 10 years. And we should probably see astronauts on the Martian service within 20 or 30 years. So that definitely will happen within our lifetime. And as I said in my talk, it could be one of you guys that will be the next human being to land on the moon or go to Mars. Okay, it is possible. So here's another question. I've always wondered about launching rockets. They always choose a specific position to launch from. That is true. Rockets are usually launched from the equator. So if you think of the Earth as a ball that's spinning round, okay, it's actually spinning faster at the equator. Okay, so why is this important? Well, when you're launching a rocket to go up into space, if it's already moving quite fast because it's spinning around the equator, you actually have to put less energy into getting it into space because it's already got a little bit of kick, a little bit of movement from being at the equator. So yes, a lot of satellite companies or space agencies such as NASA, European Space Agency, Russian Space Agency actually try and put their launch pads as close to the equator as possible. So NASA have theirs in Florida. I think European Space Agency, I think, have theirs in French Guiana, which is some islands near the equator, and Russia have theirs in Kazakhstan. Okay, so yes, we do try and get closer to the equator because where that ball, our planet is spinning faster at the equator, it gives our rockets a little kick. We need less energy to get them into space. Okay, here's another question. Do you think that the colonization of planet Mars will work successfully? It's a bit tricky. I think it it's going to be fine sending human beings to Mars and living there. The problem is, as I said in my talk, there's no, or I may have said in my talk, sorry, there's no atmosphere on Mars. There's no, the radiation from the sun is actually is weaker. There's more bad radiation, cosmic rays from space, so it's not as hospitable as Earth. So we will probably have a Martian base there, but I don't think we'll ever see any large cities there and people living there all their lives or anything like that. I don't think it will work like that. It will have a Martian base there where we'll send astronauts to and they will fly back and to from, but I don't think human beings will grow up, live there all their life, be born there in fact and die there. I don't think we will see anything like that, but I think it will be perfectly successful. We will be able to have some sort of base there from which we can explore the surface of Mars. So question here, what is the best type of engineering to do before astronomy? I would say the best type of engineering is astronautics and aeronautics, and this is the engineering behind rockets, satellites and aircraft. I studied astronautics at university and I really enjoyed it. Okay, that I did a degree in space science, so that was part physics and astronomy and the other part engineering, and I really enjoyed it. So yes, if you get a chance, astronautics or aeronautics, they're the two branches of engineering that are best placed for doing astronomy and rocketry. Okay, 21. Is there a way to have zero gravity on Earth? Yes. Now, it's something called the Vomit Comet, and I will try and send a link that you can watch a clip of it. So basically, zero G is basically when an object falls at the same speed as its surroundings. So there is a way, and they test actually astronauts doing this. They take them up in a plane, and the plane flies along, and then they tip the plane down and it accelerates towards the Earth, and if you can accelerate it at the same speed as the pull of gravity, which is about 10 meters per second, okay, so it accelerates at 10 meters per second every second, what happens is as the plane falls, everything inside it will fall, and it will seem as if you are weightless. You're basically falling very fast, but to look around you with the plane around you, you will look like you're floating. You're actually just falling. But yes, it will. You can fake zero G, zero gravity on Earth. So that's entirely plausible. It's how they NASA, European Space Agency, Roscosmos, the Russian Space Agency, they all test their astronauts this way. And the plane is actually called the Vomit Comet. And it gives you an idea what happens in there for a lot of the astronauts. Here's another question. Is it possible to create artificial gravity on board a spacecraft or in a space facility approximately the Earth's gravity? Yes, it is. Now, if you've ever been on a roundabout, and as I said in my talk, you can spin people around, you can create artificial gravity. And the idea is that if you had a spaceship that was maybe a circle or a ring, if you span it around, people on the edge of that ring, in the ring, if you span it around and around and around, a bit like a roundabout, the faster it's spanned, the bigger the pull of gravity. And if you span it fast enough, you could have approximately the same gravity as here on Earth. Now, there's a fantastic film called 2001: A Space Odyssey, where they actually show this. There's a space station in orbit around the Earth, and to create gravity on this space station, they make the space station is spinning, and everyone lives on the edge on a ring around the space station, and it's because they've got it spinning fast enough, it basically creates artificial gravity. And this is entirely possible. You can do this, and a lot of people are talking about this for a mission to Mars, that to simulate gravity so we don't impact the human beings going to Mars, we could actually have our spacecraft in some way spinning around. And by it spinning around, you could actually create artificial gravity, and this will help the astronauts stay healthy because their bones and muscles and heart won't deteriorate. Now I think that's all the questions I could answer. Hopefully it's been of use to you. As I say, it's been a real pleasure speaking to you, and hopefully I'll be able to talk to you again sometime soon. Bye bye.